Hi, welcome to a presentation about sample and population. This material is mostly related to IBDP MapSL analysis and approaches, but some may be relevant to AI as well. Okay, let's have a quick look on the syllabus. Okay, so these are the material that will be covered from 4.1. Okay. But I will take out this part here because this particular part also parallel to 4.2, so I will do this part in 4.2 instead of in this session. Right, let's make a quick start. So say you are given a data like this one here. Uh, what you will usually think is, how did the person get the data? Is the data reliable? And what does this data mean? Or what can you get out of the data? So this sort of question should pop into your head when you see a set of data, and that's what we will be doing basically in this session. Right, just a quick run through of the expectation. In this particular section, you should be able later on to tell the difference between sample and population, understand the concept of random sample, understand the reliability of the data, and understand sampling techniques. Right. Okay, what is a population and what is a sample? Okay. Population means the entire group of item being studied. And sample, of course, is a specific part of that group or a representative sample. Okay? And it is needed in order to make a valid inference or prediction based on data. Yeah? For example, um, in this case, the population is all pennies currently in circulation. The sample could be one penny from each 7th grade students. Okay? Let's take a look at some more examples. Okay, this one here. Take a look at these three cases, A, B, C. Okay? In each case, you are to decide which one is the population and which one is the sample. Okay, let's see the answer. For A, the population, of course, all American households. And sample is more specific, which is the collection of 1,353 American households surveyed. That's for part A. And part B, the population, of course, all elementary school children. And the sample is the collection of 2625 elementary school children being surveyed. And lastly, C, the population, of course, all people entering the mall within the assigned 3-hour period. And the sample is every 6th person entering the mall within the 3-hour period. Very straightforward. Okay. Let's take a look at a couple of more examples. Okay. Okay. In this case, student satisfaction with the middle school cafeteria. A survey being conducted related to that matter. Using method A, survey 40 students in 2 7th grade math classes, and the outcome is 72% are satisfied with the food in the cafeteria. And using method B, survey 65 students from a list of all students in the school, and the outcome is 85% are satisfied with the food in the cafeteria. So which one is best to represent the whole population of the school? Well, obviously, method B. the key is the survey is being given from a list of all students in the school, so it's random, rather than method A, where the survey is only given to 7th grade math classes. Okay, so the answer for this is method B. Another one, you are to conduct a survey to predict winner in an election for town mayor. If you use method C, you do telephone 100 randomly chosen voters who live in the town, and the outcome is 54% plan to vote for the incumbent mayor. And for method D, telephone 70 people who have lived in the town for more than 25 years, and 45% plan to vote for the incumbent mayor. So which method that best represents the whole population of the town voters? Well, has to be method C. Okay? Because the survey or the telephone survey is conducted involving random voters who live in the town, whereas method D, it involves 70 people who have lived in the town for a long time. So these people here who have lived for more than 25 years may have their own fixed opinion, right? So the outcome may be biased, and we want to avoid this. Okay. Right, so what actually the reason to conduct sampling inside of population? These are the main reason, because sampling can save money, because it is not conducted involving everybody, only specific group that we want to focus on. And also, it means sampling can save time. And when we talk about research, the research process is sometimes destructive. For example, if you take a look at this car here, okay, so it can be expensive if we conduct a test for each of the car produced. So that's why we use sampling, right? So if we have such advantage using sampling method, then why population is still conducted? Right? Because population census eliminate the possibility that a random sample is not representative of the population. And also, the person authorizing the study is uncomfortable with the sample information. For example, in Indonesia, we did census every year to know the Indonesian population. If you see here, the words say door to door. Okay? So the people from the government actually come door to door to take note on how many people living in the family. Okay? And it is done in every province. And what is this data for? Well, usually used for one of them, election purposes. Okay, because the government needs to know the number of voters, for example. Okay, right. So that's the difference between sample and population. Now, going back to sample, say you want to conduct a sample, then you need to decide how many sample or the number of samples that you need, considering the population size. So this table gives you some guidance. This is not in the syllabus, but this will be useful for your IA, particularly if you want to conduct if you want to collect primary data for your IA. So say if the population size is 100, and you want to be 95% confident, and you want the margin of error to be 2.5%. So you need to distribute your survey to 94 people. Okay? But if you only want to be 5%, if you only want to have a 5% margin of error, you need 80 people out of 100. Okay? I give the link here in SurveyMonkey. It has the automatic calculator that will tell you the sample size that you need in relation to the confidence level. Okay, so I hope this will be useful for your IA again if you're conducting primary data, if you're collecting primary data, right? Okay, just to recap about the sampling. Okay, take a look at this case here. The manager of a local cell phone company wants to conduct a survey to determine what kind of musical ringtones people typically use. Okay, number one. Suppose she decides to survey the listeners of a rock radio station. Do you think the result would represent the entire population? Of course not. Because if she does this, then most of the survey will answer that they prefer or they like rock ringtone, right? So this is not the best one to pick. Okay, number two. Suppose she decides to survey a group of people standing in line for a symphony. Of course, this is not the way to go, because the people there will surely choose classical ringtone. What about number three? Suppose she decides to mail a survey to every 100 households in the area. Do you think the result would represent the entire population? Yes, of course, because she selects randomly. She selects the people to answer the survey randomly. So the result will represent the population more. So number three is the best one in this case, right? Okay, type of sample. We went through the best method and the not so best method before. That's actually tells us that there are two types of samples, and they are unbiased and biased sample. Okay? Unbiased sample is a sample that is selected so that it is representative of the entire population. And the key is random. It is selected randomly. And the number is large enough to provide accurate data. Okay? Whereas bias is drawn in such a way that one or more part of the population are favored. So that's actually the difference between the two. And it is very important to consider this in your IA. Okay? Right. Let's do another example without sample. Right. Here, a 7th grade homeroom was surveyed to determine how many texts students at this particular school, Citra Pendidikan Middle School, send each day. So what is the population? Of course, all students in the school. What is the sample? Students in the 7th grade. Is it biased or unbiased? It's biased. Okay? Because one class doesn't accurately represent all the students in the school. So I hope you know the difference between biased and unbiased sampling by now. All right. Next, type of errors in sampling. Often it is inevitable, and we can divide the errors into two: sampling error and non-sampling error. Okay. Again, sampling error occurs when your sample is biased, like mentioned before. But there's also non-sampling errors. Okay, non-sampling errors are such as there's a missing data. Okay? There's a mistake in recording. There's a mistake in entering the data or analyzing, okay, the data. Or when you give out questionnaire or survey, you didn't provide a clear definition, and that leads up to defective questionnaire. And also, the people who answer your survey, they don't have enough knowledge, or they don't want to. They just don't want to respond or overstate their answers. So those are non-sampling errors. So how do we deal with these errors? Okay, let's take a look. First, we'll take a look at the sampling error. Again, it occurs when the sampling is biased. Okay? Pre-sampling means before you conduct the sampling, what you do, you need to study the area. You need to study the people in the population in relation to your study. Then you can decide on your sample such that it will not be biased. That's before you conduct the sampling. But what about the post-sampling? Post-sampling means after. How do you deal with it? Well, you can use weight. Okay? So a weight given to a data point to assign it a lighter or heavier importance in a group. Okay? You can do that. So we'll take a look at the examples. Take a look at this example here. Say a person survey some age group of people, and here is the result. Okay. So age group 18 to 34 years old, the sample result is 28%. Age group 35 to 44 years old, the survey result is 38%, and so on and so forth. But this is actually the population, right? So based on the table, the sample age, this one here, turned out to be a little younger than the overall population. So it's more toward the 18 to 34, okay, which doesn't quite represent the entire population. Again, in other words, the sample results are biased towards younger respondents. So we need to fix it. How to fix it? We apply weight. Okay, so you do the target divided by the actual. So this is the the population data over the sample. Okay. Target is the population. The actual is actually the result of your survey. So you do 24 divided by 28. That gives you 0.857. And then the target is from the population is 36 divided by the actual result, 38%. Okay, come from this one here. And the answer is 0.947, and so on and so forth. So before applying weight here, each respondent in the sample is counted equally as one person. But having done this weight, so the weight values are used instead. So each respondent in the 18 to 34 or 35 to 44 age group will count as slightly less than one individual. Okay, this is 0.857 and this is 0.947. And those in 45 to 54 or 55 plus categories will count as more than one person. So there you go. Right? So say this is a survey of 100 people, and the sample result was 18 to 34 people, 18 to 34 years old is equal to 28 people, 35 to 44 years old is equal to 38 people, and 45 to 54 years old people is equal to 25 people, and last one equal to 9 people. Now this changed to, after applying weight, to this. Okay. So the number of the 55 increases, and also the 45 to 54 years old also increases. That's how you deal with the post-sampling error, okay, by applying weight. Okay. So that's for the sampling error, sorry. Next, how we deal with the non-sampling. Okay. Again, take a look at this particular example here. Response errors occur when people so not know or will not say or overstate in their answers. Right. Pre-sampling. So before you do the survey or the sampling, what you have to do, you have to make the questions simple. And you have to train the interviewers. Okay? Or you have to train yourself before you conduct the survey. Or you might want to do pilot survey or try out or trial survey. Okay? That's what you can do before sampling. But post-sampling, what happened after sampling, if you spot any non-sampling errors, you can verify on the spot. Ask the person that you survey on the spot. Or you can ask another person, say your friends who is more expert, to do the interview again. Yeah. Okay. And how about the missing data? How to deal with this particular non-sampling errors? Okay. Well, pre-sampling, before sampling, you must always be well prepared and organized so that there's no missing data. But post-sampling means after the sampling, and you cannot repeat the sampling or the survey again, what do? You have two options, deletion or imputation. Okay, let's take a look at deletion. This one is list-wise deletion. It means that you simply delete the missing values. In this case, if you look at this row, one of the data is missing, and also this row. So in list-wise deletion, you delete those two rows containing the missing data. There you go. That's how you deal with the missing data using list-wise deletion. Okay. And next, you can do pairwise deletion, meaning only the missing observation are ignored. So take a look at this case here. Here, this data is missing and this data is missing. So what you can do is delete only these two, and then you will end up with two set of data. That is why it is called pairwise. You will end up with a pair of data. In this case, you will end up with user, device, and transaction. User, device, and transaction. And then the other one is user, operating system, and transaction. Okay. So let's take a look. So this is the first one, user, device, transaction. Okay. So this one is ignored. Okay. And so is this one. So these two are ignored. And another set is come from user, OS, operating system, and transaction. Okay. So I hope you can follow. So just by ignoring these two, you will end up with a pair of data. That is why this is called pairwise deletion. Right? Next, what we can do, apart from deletion, we use imputation. Imputation means substituting a missing data point with a value, right? So see here we have some missing points. What we can do, we can replace those points with mean. So calculate the mean of each column. Okay. For example, the mean of this column is 78, the mean of this column is 72, and so on. So you can replace the missing values with the relevant mean, like so, right? And this is called imputation, right? So which one that we should be using then? Imputation or deletion? Well, you can use imputation when you have a limited number of data. You cannot afford to delete or to ignore any of the data, right? And you can use deletion when you have a large number of data. Okay.